First of all, for this chapter, you need to understand the requirement. The trigonometry that you have studied in 11th standard, that was quite vast. If you haven't, there is no problem. Let's understand the requirement first of all. Very basic definitions of trigonometric formulae or trigonometric ratios. That is the first thing that we need to be aware about: sine, cos, tan, and so on. They're very basic definitions, and their presentation on a right angle triangle, primarily a right angle triangle. Then their relation in general triangle, relation with respect to the sides and angles in a general triangle. Then the values of trigonometric ratios, T ratios, some very specific like 30 degree, 45 degree, 60 degree, and so on. The formulae which relate the trigonometric ratios, I'll put it in simply in three categories. One is square relation, okay, then inverse relation, and a ratio relation. I'll take all of them one by one so that it becomes really easy to memorize. Now your requirement of trigonometric is only this much, okay, but because we are doing it, I'll spend a very little time, but some time on the a plus b and a minus b formula also, okay, just a little bit, right? And for your information, kind of, this is like lowest importance, the sign scheme. Beyond this, trigonometry is not required. Sometimes people get confused about height and distance, that it is a part of trigonometry. Yes, it is, but not exactly. If you have done your relation or your special triangles very well. Now when I say special triangles, means if angle given, okay, can you identify the ratio of sides? If you can do that, then you do not need trigonometry as such. But if you have done the basic definitions of T ratios, you will not face a trouble, even if it is required, or if it is like, evident that it has to be used, there will be no problem. For example, this angle is given, we have done like 30, 60, 90 degree triangle. What is the ratio of sides? That is 1:√3:2, 45, 45, 90. So most of your questions will be based on these two only, right? Most of your height and distance questions will be based on this. So don't get confused. Height and distance is not a primary part, or the way the questions will be asked from this will not be primarily from trigonometric point of view. It will be primarily from the point of view of these specific right angle triangles, sometimes a couple of more. So we'll take them one by one. First thing first, definitions of trigonometric ratios. Will follow the process of a right angle triangle. Let's consider a right angle triangle. Suppose this is a right angle triangle. I keep saying this, the beauty of the diagram is not important. Your ability to visualize the exact thing that is being communicated, that is more important. Suppose this ABC is a right angle triangle, angle B is right angle, 90 degree, okay. Now T ratios are always defined for an angle. That's the first thing, for an angle. And what are they? They are ratios. Ratio of what? Ratio of sides making those angles, right? Let's start with angle C. The first ratio that is defined is sine of C, sine of any angle. In a right angle triangle, it is equal to the opposite side divided by hypotenuse. So in the given diagram, for angle C, sine C will be equal to AB divided by AC, right? The second one is cosine. In short, it is written as cos. So cos of C, cos of C, it is always sine of C, cos of C, etc. Now cos of C is defined as adjacent side divided by hypotenuse. Now what is the side adjacent to C other than hypotenuse? It is the BC side divided by hypotenuse, that is AC, right? Tan, tangent, in short it is called tan. So tan of C, how is it defined? I'm defining the things assuming if you have never done trigonometry in life, still you will be able to understand. So these are all ratios for a particular angle. So we have chosen the angle C, and for that we have written sine ratio, cos ratio. Now we are writing tan ratio. It is the opposite side divided by adjacent side, right? So for angle C, opposite side is AB and adjacent side is, this is adjacent side. Adjacent side is BC, right? The next one is cosecant. In short, it is written as cosec. Cosec of C is equal to, it is inverse of sine. So if sine C is opposite upon hypotenuse, cosec C will be hypotenuse upon opposite side. Okay, and hypotenuse here it is AC upon opposite side is AB. So always remember these T ratios are for specific angles. Then it is secant. In short, it is sec. Sec of C, it is equal to hypotenuse divided by adjacent. You can see it is inverse of cos of C. This is AC upon BC, right? If I want to write cot C, cotangent, in short it is called cot. Cot of C is inverse of tan of C, and it is adjacent side divided by opposite side. So it is BC upon AB. Now for practice, I want you to write down sine of A, cos of A, tan of A, looking at this triangle, taking the angle A now, following these definitions, okay? Cosec of A, sec of A, and cot of A, right? So just pause the video and come back to check what these are. I'll write it. Sine A is equal to, opposite side to A it is BC, hypotenuse is AC. Cos of A, the side with A other than hypotenuse is AB, divided by hypotenuse is AC. Tan of A, opposite BC upon adjacent. Remember the definition of tan is opposite upon adjacent. So for angle A, opposite is BC, adjacent is AB. Cosec of A will be inverse of sine of A, that is AC upon BC. Sec of A will be inverse of cos of A, that is AC upon AB, right? And cot of A will be inverse of tan of A, that is AB upon BC. So this is how they are defined, right? It's very simple to understand. There's nothing great about it. Go through this once more. If you haven't done trigonometry ever in life, just repeat the last 5 minutes. Now, for the understanding to be better, let's take up this question. Very simple question. Cos of alpha is given 5/13. The question is, find values of other trigonometric ratios for angle alpha. So you can pause the video and solve it yourself. We'll use the right angle triangle. Cos of alpha is given. What you need to do is simply draw a right angle triangle, right? This is 90 degree. Assume one of the angles as alpha. So I'll assume this one to be alpha. Other than 90, assume one of the angles to be alpha. Now for this alpha, for this diagram, what will be the definition of cos? As you can see, it will be cos of alpha here will be equal to, if I give the name A, B, C, what is the definition of cos? Adjacent side BC upon hypotenuse, that is AC, right? Now, this is given 5/13. So very safely, can I take BC is equal to 5K and AC is equal to 13K, and by applying Pythagoras theorem, can you calculate this length? Here, the triplets, Pythagorean triplets help you a lot, like 3, 4, 5, 5, 12, 13. So the moment you see 5 and 13, you immediately know the third side has to be 12K. The moment you have all the sides, very easily you can find. So even if it is not a triplet, you can always apply the Pythagoras theorem, right? Okay, and you can calculate the third side. Fine. Whichever is missing, you can always calculate. Once you have calculated that, then you can calculate all the ratios. So sine of alpha will be opposite side 12K divided by hypotenuse 13K. So it is 12/13. Tan of alpha will be equal to opposite side 12K divided by adjacent side 5K. So it is 12/5, right? And then the others, which are like cosec alpha is inverse of sine alpha, and sec alpha will be inverse of cos alpha, that is 13/5, and cot alpha is inverse of tan alpha, that is 5/12. So all the values you have now just by applying this. So just remember that whatever ratio is given, identify the sides. You'll always get two sides from this ratio, and third side you can calculate with the help of Pythagoras theorem, and then you will have all the trigonometric ratios once you get the sides.